Hey all, good morning. Good morning all. Can you hear me? This is where we stopped yesterday, right? So we'll try and do this. We've extracted the data from Twitter, and then we try to. Okay, let me just reload this. 1 second. Huh? I was just trying to clean everything off. All right, so we've yesterday executed this part where we've got the data extracted using Twitter user timeline function, and then we try to generate the word cloud by cleaning the data. Right? This is what we have done. Right. So we will continue today from here. Yeah, let's wait for others also to join in. I see only 27 people. All right. Let's just wait for others to join in. We'll begin in a minute. Hey, all right, we will begin the session now. Let's proceed. We'll try and do this. Yeah. All right. Let me check. Okay, I have a question. If can you explain how created the positive versus Pranesh is just a simple text file. There's nothing special about it. You create a simple text file, keep writing all those words that you feel are relevant, which give positive impact on that particular product or the service or the person for whom you are basically analyzing the text data for. It's just a plain text file, nothing special about it. All right. So let's talk about text mining and word cloud. We have already discussed about word cloud, but let me explain about it in a small example. We'll take small example and then discuss about it. Post that, we will continue to develop the word cloud using R. Okay. So I'll give you an example here. Okay. Let's say your task is to analyze a product. Okay, you are the owner of a product, a new product that is launched, very brand new, and you are in a risk sensing team. When you say risk sensing, you basically have to try and constantly look at the customer's feedback and estimate the risk for the product in the market. For example, Nestle Maggie, if I take, Maggie was, everybody knows about Maggie, right? I don't have to explicitly explain about it. So Maggie was the market leader for noodles. In fact, noodles was referred using the word Maggie, right? So it was that popular. But just because of that one small issue, or somebody who was posted saying that Maggie has lead in it, what happened to the fate of the entire product? Gone, right? It's not in the top, probably 5 or 10 top noodles manufacturers now. So from the market leader position, it has fallen down to somewhere around 10th position or 11th position or 12th position. I would rather say that. Now, all that is because of feedback, customer feedback. Of course, lead is the primary concern. But if you would have been in the risk sensing team, and if you would have constantly scraped the data from internet, from wherever your scraping is possible, and get the data, customer feedback, and then analyzed it, then you would have probably come to know that people are talking about excessive lead content in Maggie, which is a negative, right, sentiment triggered. Now, if you would have given this information, extracted and identified back to the management, right, all together could have come up with a strategy wherein the strategy could have tried to address this particular lead issue before it blown out of proportions. Or at least you would have come up with an ad or some kind of a marketing campaign which would have rather managed the big damage that has been caused now. Right? So risk sensing is a prediction of the sentiment of the product, isn't it? So we need the data to be scraped. We need to be, right, identifying the positive feedback and the negative feedback about the product, not just positive, negative, But today we will also be trying to understand the various different emotions that our parsers would be able to capture, right? Now, if you read the reviews and then try to comment it, address those things, it's quite not possible practically. For example, you want to purchase a product. Yesterday we have seen how do we extract the product's information, reviews information from Amazon. I'm assuming we run that code, but if you have not run that, anyways, we'll run it today. So if you have 100 reviews, not 10, let's assume 100 reviews, Amazon puts 10 reviews per page. That means you have to look at 10 pages of reviews, right? Now, considering the busy schedule that we have nowadays, investing time in reading 10 reviews would quite be a difficult task. I'm not saying impossible, but it could be quite difficult task for a few people. For me, I don't even look at first 5 reviews. It's really difficult. I don't have that kind of patience, right? Now, if I have 1,000, if I have 10,000, every customer is important, remember. So each review would be very, very important for us, right? You cannot ignore even 1 or 2 reviews. So I want to get the information from all the reviews, right? So what we do, again, we extract the data, we tokenize the data, we filter the data, we create bag of words. That's basically how we structurize the data. And using that bag of words, we come up with this particular word cloud arrangement of the words. So let's talk about that. Yeah, so this is again something we have already seen. When we talk about text mining, text data, majority of the text data would be unstructured, right? We'll not have structured data so easily. Yes, if you can talk about employee database, we will have structured data here. Few fields would be text. For example, the name, right? The address of that person, or probably you can say the designation, etc. There could be text data which can be explained as a structured data. But look at this. The majority of the cases here that we are getting would be unstructured in nature. Call transcripts. You're calling a customer care. Let's say for credit card or any other service, you're making a call to that respective customer care center. The customer care center, right, they would address your call, but they will also, I mean, when they are speaking to you, there would be a message saying that this call is getting recorded, right? So that call that we are talking about, whatever is getting recorded, would be then be converted into voice to text format. And once it is in the text format, archive it, and then you analyze that particular text data to do various things like frequently raised concerns, the KRAs of the executives, whether they are addressing the issues properly or not, what kind of grammar they are using, whether they are harsh, and all these things can be addressed. Email to the customer service. You're raising a customer request, I mean, service request. You're writing an email. Probably there would be in a formal language, but ultimately it's an email which would be in unstructured format, right? Then we have social media outreach. There are a lot of social media data which is populated. We can extract it and we can try and do this. Of course, there are a lot of restrictions here. GDPR norms are there. We're putting a lot of we have to face a lot of restrictions in order to extract the data. Of course, it's not quite possible now. But still, if you can get the data, you can do a lot of analysis like what we have done yesterday with Twitter. Speech transcripts, any important people when they try to give these speeches, those speeches will be written. In fact, they would the news channels, they would publish these transcripts directly for our access, right? Field agents and sales people, they collect a lot of data. They visit places, they visit customers, and they record a lot of information. All that would be in unstructured data. And what is this? Interviews and surveys. If we talk about the crisp DM steps, the first step would be the business problem. The second step would be the data collection. And data collection comes in two variants, or we can do it in two variants. The first one would be this. If your data is not stored somewhere, if it is getting generated and you want to collect the data directly from the source, then we call it as primary data sources, right? And in order to get that data, we conduct surveys and interviews. And this data can be in unstructured format. So there are various ways where you can get the data. Now let us assume what we are doing here. I mean, assume that we have data and we'll try and understand what exactly we are doing here. So this is kind of a revision of bag of words or your word cloud. So this is the Shakespeare's statement, I mean a novel article. All the world's a stage and all the men and women merely players. They have their exits and their entrances, and one man in his time plays many parts. So as you can see, these are 3 lines, or you can say a paragraph from a play of Shakespeare. Now, if you look into the in-depth context or meaning of this particular sentences rather, for an English professor, yeah, he can talk about the literature. This very in-depth literature is there. But are we interested in the literature? No, right? We are not going into the literature. To begin with, we want to get the data, text data. So we want to get this unstructured data to structurized. This is unstructured. We want to get that into a structure format. How would you do that? We have to first collect and then pre-process the data before you break that data into structured format. But for that, we need to, of course, understand the language quirks, or you say the language itself. So for the pre-processing, what all steps did we do? Data cleansing, or we call it as data pre-processing. Of course, the terminology is something that you have to remember. The raw data that we are getting, the raw data is called as corpus or corpora. But this raw data is collection of entities, individual entities. Those individual entities are called as documents. The best example I can explain here is one paragraph in that Shakespeare's play would be one document. There will be multiple such paragraphs in the entire play, right? Collection of those documents is called as corpus. If we talk about reviews, for Amazon, for example, we are going to anyways extract the data, right? So the reviews that we are extracting, those reviews are documents. You are writing a review, I am writing a review, some other person is writing a review. Individuals write the reviews, right? So each review is called as document. Irrespective of the size of the review, mind you, we are not talking about the size here. The size would not be consistent. It is unstructured in nature. Irrespective of the size, one review is one document, right? Collection of all those reviews is called as corpus or source. Now, once you have the corpus, the raw data, then we have to clean it. Now, while cleaning, these are the various things that we have learned as part of the webinar series that we have conducted today, till now. The first one would be, of course, the typos. There is no order here. I'm trying to use the same order, but you can do anything here in any order. There's no fixed order here. The first one is the spell check, typos. We have seen there are a few packages which are used for typos as well. In Python also we have run those things. Or you can also use any third-party tool to make the corrections. Because we're taking one word as one token, right? We are collecting those tokens. And then we'll be working with those words only. So make sure there is no mistakes. Because let's say you're taking a data of, let's say, a mobile, right? Like what we have extracted yesterday. In that particular extracted data, somebody is writing the word MUSE. He wanted to say that the music that was played in the phone was of good quality. The output was good quality. Something along those lines. Now, the correct spelling would be music. Right? A lot of other customers are also representing something related to music. But when you're collecting the words, when you're collecting the tokens, creating the tokens, if you're not correcting the typos, then you would get this as one token, this as one token, separate words. Your machine does not have that intelligence to do it automatically, understand it automatically that these words are same. Right? So we have to make sure that we are correcting those typos. Then we also have to make sure that the entire text is following a consistent case. Again, the same thing. If you have different cases, this becomes one token, this becomes another token, this becomes another token. Because your programming languages are R and Python or any other tool that you might want to use in future as well. Till now, all those tools are case sensitive. Okay. All the tools, they are case sensitive. So we will have three different tokens. But from the user perspective, all these three are representing the same point, right? Or the same feature of the product. So we have to make sure that there is a consistency to make sure that we are treating that as a single feature command. Then we have also learned about removing the special symbols, punctuations, because they do not add value when you are doing the bag of words extraction. So we have to clean this punctuation marks, special symbols as well. Then we have filler words, connectors, pronouns, stop words. We call them as stop words. In Python, how many stop words are there? Let me see the messages. In Python, how many stop words are there? Very good. In R, okay, 179 stop words, predefined stop words in Python. How about in R? Very good. 174. Exactly. So these are predefined, but again, you don't have to confine yourself with this. You can have your own customized words as well created. right? So you can have your own words and define that as set of stop words. And we would filter these stop words away. Because when you are talking about any text data, these words are used to connect two keywords. Now, if you look into that, if you are trying to look into those words, a word cloud, ultimately remember we are going with the frequency count. These words would have very high count compared to other words. Yeah. So yeah, the problem is your word cloud would get highlighted with these words, which do not give you any contextual meaning from that particular text data that you are analyzing. So we have to clean this. You might want to remove numbers if there are any numbers, right? If you don't want specifically any words, you can remove those words. And ultimately, when you're cleaning this entire text data, there would be some spaces created, right? Empty spaces. So we also have to remove those empty spaces, because ultimately your data, which is in English language, we are talking only about English language, is a space delimiter language. If you have two spaces, then again, it doesn't make sense, right? It's not following that syntax. Now, we can also do stemming or lemmatization. That is also something that we have learned. So we first tokenize, then remove all these unwanted things. We can also add stemming or lemmatization, right? We know the difference, right? Stemming and lemmatization. Stem and leaf words are identified, and in stemming we take only the stem words irrespective of whether it is giving a dictionary meaning or not. Where in lemmatization, the stem words are considered only when they give a similar definition. If the stem words are giving different meanings in conjunction with leaf words, then we do not split it. Right? So this is a little intelligently done. So we are basically trying to gather the words which give you the similar contextual meaning. So these are the steps that we will have to do. Of course, various other things also can be done based on the requirements. Now, once you tokenize, let's say you've cleansed it and tokenized, all these things are gone, right? And you're taking only the important words, probably exits, entrances, man, time, place, paths, so on and so forth. So once you clean this data, you're left out with only these keywords. And we are collecting those keywords, and we are also making sure we are counting the words repetition. Word is repeated only once in this particular document. Stage is repeated once. Men is repeated twice. Where do we see men twice? We have men, we have women. We don't have men anywhere else. Singular and plural. Man is there, right? So man and men, these two give you the same dictionary meaning, right? So we are considering them as same word. So here man is repeated twice. Woman again one, play is twice. So here assume we are doing stemming. So this is players and plays. There are two words. So from this, we consider play only, right? And counting it as 2. Then we have exit, then we have entrance, then we have time, then we have various other words. So what we are doing, we are considering the unstructured data, pre-processing the data, and converting that unstructured data into a structured format. Now this structured format data is called as BOW, bag of words. Now once you get the structured data, you can perform a lot of analysis on that data. So LSA, LDA that we have learned yesterday, they also work on this particular documents only, right? Bag of words only. But this bag of words is applied onto a single document. Now, if you are collecting a lot of documents, let's say we are extracting data from Amazon, right? So let's work on that. We will not have one review. We'll have multiple reviews, right? So we have to apply the same logic to all the reviews that we are extracting, right? So assuming that we have 100 document corpus, that means we are extracting 100 reviews. We are working with 100 reviews. Take the first review, put it here, and apply bag of words. We will get this matrix representation. First review is plotted here. Second review, third review, fourth review, so on and so forth, 100 reviews. For each review, you perform that bag of words and accumulate them in the matrix representation like this. For example, the word keyboard is present 4 times in the first review. USB is present once. Free is present 0 times, it's not there. Hard is present twice, so on and so forth. Right? So you're accumulating the keywords. Now, when you are taking only about bag of words for the first review, you will have only the words which are present in that particular document. Right? Next, you'll do the second review. Now, in the second review, you might have the same words and you might have additional new words. You arrange them here and make the count. Keep repeating. So you will get a bunch of words, keywords, which are present in all the documents. It would be, of course, a sparse matrix. Sparse means a lot of zeros would be there. Not everyone uses the same words to write the review, right? So a lot of empty spaces might be there, but that's how this matrix is generated. So this bag of words that we are conducting on all the columns will give us this matrix, which is called as document term matrix or TDM, term document matrix, which is nothing but documents arranged in rows, terms arranged in columns. So whenever you talk about a matrix dimension, it is rows by columns, right? So that's the nomenclature for this representation of the data. It's just the arrangement, where you want to arrange the documents, where you arranged the terms. Based on that, we either call it as DTM or TDM. Now, what we're doing here is we are accumulating all these words, right? And then looking into the total number of times each word is repeated. How many times each word is repeated? Now, this sum of the values will give us an interpretation on what is that particular feature which is popularly being discussed among all the customers. If you see, the word keyboard is repeated 200 times. Whereas USB is repeated only 50 times, free is repeated only 100 times, hard is repeated 80 times, so on and so forth. So by looking at the frequency, I can say not many people are talking about USB, but a lot of people are talking about the word keyboard. Right? More number of times the word is repeated, that obviously means that it is a popular word, right? So we take the DTN, which is in structured format, we call it as a key and value pair, key value pair representation, which is nothing but structured formation. We take the keyword and the count, or I would rather say frequency, as a pair. And we try to represent this in the random white space, in an X and Y space, randomly arranging these keywords that we are getting. But when you're arranging to give the difference of the importance of the popularity, we look into the frequency and we arrange it this way. And all we are doing is altering the font size and saying that if a word is repeated more number of times, it should have a larger font. If the word is repeated less number of times comparatively, then it should have a less font size. Random arrangement. Right? Now this is a simple word cloud that we are generating from the corpus. Hence it is called as corpus level word cloud. Right? Now there are certain challenges that we have to look at. Again, this is a repetition. We have already done this. But let me quickly do that and then we'll go to the code. If you look at this keyboard, right, assume the keyboard is represented by, we have 100 reviewers, right? Out of 100, only 40 members has representing the word keyboard. But all those 40 members were representing the keyboard, let's say in a double-digit number of times. Like this. So when you do the sum, obviously the sum would be larger. But whereas, let's talk about the word free. This word is represented by, let's say, 80 people, 80 reviews. But the word is not, let's say, repeated too many times. It's single-digit number assumed. Now, this is one of the ambiguity that you will have, because from the word cloud interpretation, we are seeing that if the sum is larger, the font size would be larger in the word cloud. Isn't it? That's the interpretation that we are taking here. But from the understanding perspective, if you deep dive into the reviews itself, which is more important? Is keyboard important or is it free important? From the example. Which is more popular? Among the 100 reviews, if more number of people are talking about a specific feature, that means that particular feature is more important, right? Or more popular. Right? Compared to the keyboard, for me, free would be more important. So if you look at only the sum, then you might get this kind of an ambiguity. There might be another scenario. Let's say the word keyboard is represented by only 40 people. That's the example that we are taking. "40 reviews" is what we're talking about here. And let's say the first review I have written. Okay, I have taken a lot of time to write the review, and probably I have come up with a 300-word review. And out of that, I am representing the word keyboard 34 times. right? Now, just because of this one value, 34, one reviewer, the count increasing here. The overall sum increases, isn't it? And when you look into the word cloud, you get the interpretation that the word keyboard is the popular among all the customers. That's what we see, right? Because the font size increases here. Larger the font size, the interpretation is popular the feature among the users. So this is an outlier. Right? This is an exception. So to handle all these kind of cases, we have TF-IDF, term frequency, inverse document frequency. This is also covered, we have in detail discussed, but let me just quickly give you a high level interpretation here. TF multiplied by inverse of document frequency. That's what we basically treat this as, right? Now, term frequency can be looked at as the proportion. We don't take sum. Remember, we should not take sum because of the influence that we are getting, right? It's not properly interpreted. So what we do, we take proportion or percentage. To give you an example on this, let's say there are these two reviewers. Customer one is me. Let's take the same example. I have used a review, or I've written a review which is of length 300 words. Let's say the second review is written by you. You have written a small review, only 30 words, right? And if you see here, let's say I have come up with the review with 24 words, 24 times repeated, the keyword. And for you, it is only repeating 3 times. Okay. Or let's say only 14 times or anything, whatever the number is, right? So if we have the first review which has 300 words, out of which we have 24 times the word repeated, compared to the second review which has 30 words, where the word is repeated 3 times, if you look at only the sum, the count, for me, I would rather say that the first review or first reviewer is throwing more emphasis on the word keyboard. I would say he has given more importance to the word keyboard. But ideally, if you look at it, probably the second customer might have given more importance. So we have to look at the proportion of the word being repeated in that particular review. That proportion would actually give us better interpretation. For example, for this customer, I would say out of 300 words, 24 times he repeated. So if I convert this into percentage, what would be this? Yep, it would be 8%, right? What about this? 3 by 30 into 100. So this becomes 10%. That means the second reviewer is throwing more importance. He is giving 10%, right? Contribution, or the word keyboard is having a 10% contribution in that particular review, which is more compared to 8%, isn't it? So this is what we have to look at. 8% is less compared to 10%. So we take the frequency in the terms of percentage or proportion. That would actually tell us the importance of that particular keyword in one review. For that particular reviewer, what is important? Okay, that's your TF. Now, document frequency is on the similar lines, if I have to explain. Document frequency is the overall popularity of the word. That means if I have 100 documents or 100 reviews, if the word keyboard is repeated only by 40 people, 80 people, right? Among 100 reviewers, 80 people are talking about it. So it is more popular. More people are concerned about it. More people are happy about it. So this word, which is free, should be more or given more importance than the word keyboard, right? So that is basically your calculation or interpretation here, right? So TF-IDF is a weightage mechanism which is addressing all these issues. The formula you have already learned, TF-IDF. Yeah, you can say weightage is TF multiplied by log of total number of times the word is repeated in a document. This is something your document is calculated, right? This is the formula. You're inversing it. All right. Now, once we have this, we generate these word clouds. So this is the theory part, friends. And of course, interpretation would be a little challenging because interpretation of the insights, the context from a pure simple word cloud would be manual. It has to be manual because word cloud does not talk about the sentiment. Sentiment interpretation should be manual. The positive words and the negative words that we are generating, right? Now, if you look into this, let's say I'm talking about, my favorite word, hot. The word hot is present in positive word clouds. That is because probably you're saying that, or when you created your dictionary, the positive word dictionary, you imagine that, okay, hot could be a word which is positive. You might have imagined that there could be a review about a product offer, and people might have written or write about that hot deal. So the word hot coming in the positive dictionaries for you. This is a custom dictionary, mind you. So you are creating this, right? So you have placed the word hot in the positive dictionaries. So when the word cloud is getting generated, we look at all the words that are extracted. We refer to DTM or TTM. We take all the keywords and we compare it with the dictionary. And then we publish the words which are present in the positive dictionary here in a positive word cloud. But do you think the word hot would always be in a positive comments? No, right? The word hot could be written by customers who were talking about the device becoming hot. Device is getting hot. That's a negative feedback, right? So as I said, the context is something we cannot control or we cannot interpret, right? Yeah. So these are the drawbacks, of course, in the word cloud. And for that, you have parts of speech tagging. Then we'll have named entity recognition, right? Those concepts will come into the picture. But from the word cloud perspective, this is what you have to understand. Right. So this is about the word cloud. And then, yeah, let's now go to the R code and try and understand the R code. Okay, before that, let me see if you have any questions. Can you please provide the steps to invoke GPU processing from Python and the pre-installation steps for this? GPU processing. There are certain steps, Ranganath. My system does not have GPUs. Yeah, I can help you with that offline, Ranganath. I don't have those steps handy, but it should be pretty easy. Yeah, I can get those steps for you. Voice dropping. Okay, voice dropping. Is my voice clear, friends? Yeah, sure, Ranganath. Yeah. Will these videos get? These will be there in YouTube, Awaze. The Saturdays and Sundays videos, they will be there in the YouTube. Can we place words in both positive and negative dictionaries as well? Yeah, absolutely, Sheikh. That's your wish. As I said, it is a custom dictionary. You define what you want. And your machine just follows your instructions. That's it. Video quality is still. Pranesh, I am not sure. Probably, yeah, it could be something related to your internet connectivity also. So probably you have to cross check that once. Yeah, can others comment? Do you see the video quality as poor? It's not streaming properly? Clear, right? Okay. Okay. That could be an internet issue, Pranesh. I don't have control on that. All right. So we'll do one thing, friends. We'll take the break now. And we'll return back. And then we'll continue discussing about the R code. All right. So it's 7:54 now. Okay, we'll return at 8:1. Okay, we'll resume at 8:1. All right. All right, let me see the questions. Do we have any specific, okay, do we have any site showing? No, no, no. How can that be possible, Rishikesh? That cannot be possible, Rishikesh. We're talking about custom dictionaries. For custom dictionaries, there is no predefined thing. You have to create your own. It's just a text file, Rishikesh. For example, you are talking about a mobile phone. What all words do you think would be positive? Readily available few words would be there in the Google. You can just try and search for them. And on top of that, you have to build your own words. We don't have any predefined ones like that. Right. Assuming everyone is back, do we have everyone back? Rohit, okay. All right, yeah. Don't worry, I'll not drag the session too much. We'll conclude early, being Sunday. Don't worry. So I'm not ruining your Sundays, okay? Don't worry. All right. So we have to extract the data from Amazon, and then assuming that you want to purchase a product, you are trying to do sentiment analysis on top of that. So let us first install the packages and load them. So I already have these packages installed. So I'm just loading these 3 packages. Okay, RWES, XML, and mag RITTR. Then we are loading the URL. This URL is basically pointing to the reviews page. And in the reviews page, we're not putting the page number. We are just taking the URL till the page number, not the page number. So if I go here, this is my review page, right? And if I scroll down here, I get next page. And when I click on the next page, the URL will automatically have that second page number. Right? It is getting those page numbers attached. So we will decide the number of pages here by assigning the number here at the end for the A URL. That is done using the for loop. I'm defining a empty variable, Amazon underscore reviews. And then I'm using these inbuilt functions, predefined functions. Okay, read HTML is to read the content in HTML format. For what we are reading the HTML content? For the URL here. So you're pasting the URL. You say AURL, that's this URL. But that URL does not have page number. So I'm putting a separator equal to and then putting I. This is how I construct the URL. Okay. Now, once you construct this URL, you're saying read this URL, the entire URL as a character, and then read the content, HTML part of that particular URL. When you say HTML part, you come here and you can say right click, go to the view page source. If you do this, You will go to the HTML source page here. Yeah, this is your HTML code that will be given when you say view page source. So you are trying to read this content. Here, read HTML, okay? And once you are reading it, you are using the pipe function. These are called as pipe functions to execute and extract the data in the same order. Generally, what happens in R or any programming language is when you're writing a multiple command. Say, for example, if I say a simple mathematical calculation or multiple things that I want to do, log of, let's say, a variable x, but I want to square that, right? And probably on top of this, I want to do square root. When you do this kind of a calculation, the calculation happens from right to left. So first square is done, x square, we calculate x square. Then we do log of x square. And whatever we get, we apply square root on top of that. So we are executing from right to left. This is a typical execution flow. But when I use this pipe symbol, we are saying follow this order. Execute it in the same way. Right? So first take MURL, that means the HTML content. From that, you want to identify the content, HTML content, which has this particular tag. So I will take this tag. We want reviews, right? So I will say review underscore review hyphen text. You can use multiple tags, but ultimately what we want is the tag which gives us the review body. You can either put the review text or you can put the entire thing here, this entire thing, to get the content. Right? That is this content, the review part. So it is saying identify the tags, nodes. Identify all the nodes. And then HTML underscore text. This is a function which is extracting that content. So if I do question mark of HTML underscore nodes, you can say select nodes from an HTML document. Right? You're specifically saying, hey, this is the node that I want to highlight or choose. Then question mark of HTML underscore text is to extract the data, extract attributes, text, and tag name from that HTML source. When I do this, it is identifying all the tags, and then from that tag, it captures the data. So here it is identifying this particular one, and it is extracting this data and storing this into review, REV. It's storing into REV. But this is not all. This is just one review. It goes again down. This is the second review. Again, it gets stored in REV. How? So first review that we are storing in REV is getting appended or is getting added into Amazon underscore reviews. It's getting added here. Right? Initially, your Amazon underscore reviews variable is null. You're adding that with REV, first review, and storing it back into Amazon reviews only. So Amazon reviews will now have first review. Then goes back. It again captures the second review. Like that, it captures 10 reviews because in each page for Amazon, there are 10 reviews prefixed, predefined. That's the structure. So it captures those 10 reviews and store it into REV. Then again, it goes back to the for loop. After the first page review is done, it goes to increments that I to 2. We reconstruct the HTML page with second page reviews and then repeat the steps. So we'll repeat this till we get all the reviews done. Yeah. Yeah. Friends, are you able to hear me? Just want to confirm. This function would change as per the URL. Which, okay, library. Sheikh, you have to install the library, right? If you don't have the library, the XML library has to be installed. This function would change as per the URL. Not really. Your R Java is not configured properly. You have to configure R Java properly. Yeah, then only you'll be able to install it. Is that issue resolved? Are you able to install? Yeah, we can discuss that offline. Yeah, Sheikh, if it's not working, then we'll discuss that offline. All right. So we have to repeat the steps for 20 pages. It's going to automatically repeat it. It's a for loop, right? It's doing that. All right. So let me execute it. And it is now extracting. Initially, the A reviews or the Amazon reviews is a null variable. Yeah, done. Now you can see that it has extracted 200 reviews. Each page has 10 reviews, right? And we are extracting from 20 pages. So you will get 200 reviews. Now those reviews, I'm storing it in text file. And if I say get WD, this is the location. These are the reviews that we have extracted. Yeah, first review, the battery lasts max for 6 hours, so on. So 1 plus 60 turned out to be an utter disappointment for me, and so on and so forth. These are multiple reviews that the customers have given, and we have 200 reviews. Right? So that's how we extract the data. Now, once the data is extracted, as I said, let us now perform the sentiment analysis. We'll try to extract more information from this particular data. So the Amazon reviews that I have extracted, I'm directly saving it to a variable txt. But make sure the variable or the data that you're working on is in the character format first to begin with. If it is in data frame format, then you have to change that to character format. You have to say as dot character. If in case your customer is providing you the reviews in a structured format, you have to do this. Make sure the input is in character format. Then length, you can cross check, it is 200. And if you say view, it is going to show you the content. Yeah, these are your reviews. Okay. Now, we have seen yesterday with the Twitter code, the package that we have to work with is the text mining package, TM package. If it is not installed already, install it and load it. And then convert this character data into corpus. For text mining package in R, the data has to be in corpus format. Yeah, it has to be in corpus format. So we are putting this as corpus. Vector source corpus. Inspect. When you do inspect, it shows the content. It is in a list format, right? It is not in a data frame format. So it has to be done using this inspect command. Now, whenever you're working with these kind of extracted data, right? The data which is there on the internet could be following different character sets. Okay, different people will have different strategies. So they might have come up with different character sets. The text mining package that we are using, right, is designed to work with certain character sets only. It will not work for all the character sets, right? It's like the format that the pages are written, the language is written in. So we have to make sure that we are converting everything into a standard character set, which is UTF-8. So I'm writing a custom function here, inline function, and I'm saying pass this as input, and when you pass one input, the input will be converted to UTF-8. I convert, that's the function name that I'm giving, and I'm saying encode to UTF-8, right? For all the input data that you're passing at a byte level, do this. So now your data has been converted to UTF-8 character set. If you don't do this step, if you're not doing this step, a lot of content will not be read. TM package will not understand all the different special characters and all this. So you'll lose on a lot of data. Right? So hence it's kind of a mandatory step that you do. Now, once you have the data, right? Once you have this data, we start cleaning it. First and foremost, try and convert everything into the lowercase letters. This is in caps, D, T is in caps, B is in caps, right? A is in caps. So you want to convert everything into lowercase letters. And that converted data, I'm storing it into a new variable called x1, not x, but x1. So again, you get x1 here, which is a list of 200. If you say inspect of x1 now, you see that the entire text is in lowercase letters. You're passing it to lower, right? That's the function which is converting everything into lowercase. Then there are punctuation marks. You have special symbols, punctuation marks, and all those things. We will remove that. Remove punctuation. So all the full stops and all those things are gone. Numbers are there. I don't want numbers. So I will be removing the numbers. All the numbers are gone. And I will remove the predefined stop words. As I said, we have 174 stop words. If I just select it and execute, it shows those 174 stop words here. So let us remove these stop words from our data. And you see, wherever that word is removed, there is an empty void space created. Right? So I want to remove those void spaces, empty spaces. And when I do the strip white space, this new line character, which is also creating extra lines and extra spaces, those things also will be gone. Oops, sorry, yeah. Look at that. So I cleansed the data, right? On top of this, if you want to perform stemming, lemmatization, and all that, you can further do it. I'm skipping that part here. And then coming up with term document matrix. You can either do document term matrix or term document matrix. You can see both the functions are there. As I said, you can work with either of these. There is no restriction. It's just the arrangement of the data. So if I do TDM, then I would get a sparse matrix, and yeah, I have this error, which is ignored. Okay, don't worry about that error. It's working only in my system. I mean, it's generally occurs in my system with the error, probably because of some package issue or something like that. But yeah, you can ignore it. So in total, I have 3084 words extracted, and I have 200 documents. I mean, out of 200 reviews, we've extracted 3084 words, and this is a TDM, term document matrix. So it would be in this form. You'll have terms here. Terms are keywords, right? And you will have documents here. First document, second document, third document, so on and so forth, 200 documents. And you can see the sparsity, non-sparse entries and sparse entries. So in this big matrix, which is of 3084 into 200 dimension, there are a lot of cells which do not have any entry. Zeros would be there, because not all words might occur in all the documents, right? Hence we call it as a sparse matrix. We can convert this TDM to DTM either by doing a transpose or directly generating the document term matrix on the data, like what we have done previously with TDM. Both will give you the same results, nothing changes, okay? It's just the arrangement as I said. And if you execute only TDM, it reverses the documents and the terms position. So now you can see it is documents, and here you have terms. Right? So yeah, nothing changes actually. All right. Now to remove these sparse entries, right, we can execute this particular remove sparse terms. On the TDM, I want to remove the sparse entries. This error that you are seeing, right, error in n characters, type characters, that is occurred because you have sparse entries in the TDM. You would change the percentage of sparsity. Here you can vary this, and you're removing those sparse entries. You can do a question mark of remove sparse terms from the TDM. And just do this. A numeric for the maximal allowed sparsity in the range from bigger 0 to smaller 1. I'm saying 0.99%. Now, if you basically use this DTM, this is a DTM now, okay? You see that, right? All those things are no error basically, right? Yeah, this is to clean up the data. And yeah, we'll not use this here for our discussion. We'll continue using all the words. It basically says if any word is having 99% of sparsity, remove it. Right? And there are only 754 words remaining, which do not have such a high sparsity. Right? These words have 95% sparsity. Right? So this is how we can eliminate those sparse entries beyond a point. Right. But yeah, as I said, we are not working with that. We'll be working with the complete data set. I just want to have more words in my word cloud to show you. So I'm using 3084 words. But this is in a TDM format, which your computer, which your machine or R programming would not understand. So I'm converting that into a readable matrix format as matrix, the plain matrix. So you can see here it says now large matrix, and it gives you the dimensions 616,800 elements. Those many elements are there in the TDM. If you see the dimension, it remains same, nothing is changed. But don't try to view the entire matrix. You need to have a supercomputer to do that. So you're simply doing 20 rows, 20 columns, just to have a glimpse on what your data is talking about. Yeah, these are 20 rows and 20 columns. Terms are there on the rows, and the documents are there in the columns. And you can see the numbers, zeros and numbers. Look at this. Phone is repeated in a lot of documents, right? And this particular one, which is a 14th document, has the phone being repeated 11 times. It is repeated 8 times here. What is this document? 7th document, right? And because we are talking about the first 20 terms, you can see the first document will have all those words. Right? You go to the few more additional things. Second document would have numbers. Few other words. Third document would have numbers. Right? So sequentially, it is taking one document and collecting their terms. So this is your DTM. We are ready with the data. Now on this data, we have to come up with the word cloud. But in order to come up with the word cloud, we need the keyword and the sum of the keywords, how many times the word is repeated. Right? So let's go there. And I'm doing row sums on TDM. What would I get if I do row sum on TDM? TDM is this arrangement where terms are there on the rows, documents are in the columns. I'm doing a row sums. That means add all these values, row sums, right? This would give us the sum of each word being repeated, each term repeated in all the columns. Right? How many times each word is repeated in all the columns? That's your row sums. So let us do this. If you are using DTM, you can say column sums, COL sums. That's the only thing which you have to keep in mind, okay? Because for DTM, documents would be there here, terms would be there in the columns, right? So the arrangement changing. So let us do this. Row sums. And if I click on W, it will give two things. This word W or the variable W has two things. The key and the value. Key is the word, value is the total sum. It holds two things. Okay? So let me show you that. So word and the sum, word and the sum. In the console, always remember, in this console, only 1000 lines of output will be shown. In total, I have 3084, right? So 2084 words are omitted. It's not able to print there. So we have the words. Now to view the most frequently repeated words, you want to understand the popularity, right? So try and look at the most frequently repeated words. So I'm using the subset function to shortlist only those words which are repeated greater than or equal to 65 times. These are the words. So we'll come up with the bar plot. Just say bar plot on W underscore sub. Then you can put colors and all that. Now what is that we are seeing here? There are few words which are having high popularity. Phone, OnePlus, also. Anything else that we might want to consider removing? We are doing the review for a mobile phone, which is OnePlus. This is the brand name, right? And it is obviously product phone, right? You might also remove 1 and plus, because some people will write 1 plus, right? So you might want to remove these words as well, which are not required, right? So if you want to remove those words, you just use this remove words and mention those bunch of words that you want to eliminate. Using the concatenate function, you are saying remove these set of words. They do not add any value for your interpretation, right? Obviously, you're doing the analysis for phone, so people will use that word, not required. So you are removing those words. And wherever that word is removed, these words are removed, space is created. So I'm again stripping those white spaces, recreating the term document matrix. And if you see the dimension, 3 words are removed. Phone 1 plus will. You can add more words if you wish. Convert that into a matrix format so that we will be able to read it, regenerate the row sums, and recalculate the sum. This time I'm taking more words. Less than or equal to, greater than or equal to 50 is what I'm putting here as a count. And these are the words that I'm getting. Now again, you come up with a bar plot for these more words, and you can see 1 and good are having the highest frequency. You might want to remove that. Just is also another word that you might want to remove, right? Probably you might want to remove can, get, like. It's your choice. Okay, you have to take a call on which words you might want to consider, which words you might want to remove. Now we have a function called word cloud. Just execute it. And for the word cloud, 2 things are required: the name and the sum of that particular repetitions. This count. So I'm taking words is equals to, if you see the output here for w underscore sub, as I said, it contains 2 entries, the word and the frequency. So the word I'm passing as the names of this w underscore sub, and frequency is the number that it carries. Do that, that's it. Yeah, and it's not able to plot it because of the font size, because of the space and all that. So it is giving that warning message as well. Yeah, this is the output. Not good looking. Right? We want to come up with more things. So what we'll do, I'll take all the words, I'm calling it as W sub, but I'm arranging them in the decreasing order of the frequency. All the words. Right? So if you say head, it gives you the first 6 words. Now I'm coming up with word cloud on all the words, which are in decreasing order arrangement. When I do this, it will take a while to print. But again, because of the screen resolution and all that, it is not able to print everything here properly. So we have an alternative or workaround for doing that in a better way. We'll do that now. Yeah, this is executed. But it's not showing complete words, right? So what we can do is, to begin with, we can add parameters. You can see here, I'm adding parameters, random order false. That means always publish these words in a decreasing order, whatever the order that you have the data in. Then colors, I'm adding different set of colors. 30 different shades would be used from the rainbow colors. Then the scale, the font size is also something that I'm controlling. It has to be ranged between 2 to 0.5. And the rotation percent is 0.4. By default, the words would be in horizontal arrangement. But you're saying 40% of the words can be arranged in vertical order. So if I do this again, it will not give a good output, though it is now giving colors. but still it is not publishing all the words in the entire space. So we will use this function called windows. This would work only in Windows. For Mac, you have to do quads and then come up with the function. This function would give a new window. And in this new window, we are publishing the word cloud. We have 3000 odd words, right? So all those words are printed here. Now, if you feel that, no, I don't want all the 3000 words, I don't want the words which are repeated once or twice, you can eliminate all those words. You can decide what would be the maximum frequency of the terms that you will want to shortlist. And only publish those words here. That probably will give you a better interpretation. I can also change the font, Windows font. I'm using MS Gothic and I'm publishing the word cloud. This is to change the font size. Sorry, font. Not size, but the style. These are additional parameters that you might want to apply for beautifying the output. But yeah, this is not the end. Still long way to go. We have a package called Word Cloud 2. Install this package and load it. And for this package, we need to have a data frame, two different columns, the same input, frequency and the words, but it takes the data in a data frame format. So I'm converting the names and the frequencies into a data frame. You can see W1 will have the name and the frequency. So I'm changing those names. I'm giving a proper name to that word and frequency. And I'm passing the W1 as an input to the word cloud. And this word cloud 2 will give shape. Not just shape, but it also gives us frequency. It is highlighting the frequency as well here. If you see here, when I hover my mouse, it gives you the count. Right? Circle is not properly given. Yeah. So you can see the shape. It's randomly trying to arrange the words, but in a circle shape. Similarly, we'll do it in a triangle shape. We'll do it in a star shape. So you can explore and generate these different visualizations to attract. I mean, it's just the words that you are arranging in different styles. So when you're presenting your report to your client, probably you might want to add this enhancement into the visualization. Now this is about a unigram. Right? Now let us learn how to do the bigram. So for bigram, I need Arvika and word cloud. These are already installed. So I'm just loading them again. And the minimum frequency bigram I'm taking as 2. I'm defining a variable, min frequency underscore bigram, and sending a value of 2 to it. And n-gram tokenizer, I'm using a function called as n-gram tokenizer. And deciding how many tokens, size of the tokens here I'm giving as 2, max also 2. So that means you're saying break the words into 2 words token. This is your byte token, it gives you the byte token. And if you want to look into that byte token, if you say table of byte token, it gives us the count. 2 words together, how many times it is repeated. I'm converting that into a data frame, the output into a data frame, and I'm saying 2 words. There are a lot of junk characters, friends. We have to eliminate that. We have not done that cleaning properly. At the initial stage, we have to clean all this. And I'm arranging these words in the decreasing order. Okay. Now I'm using this particular Yeah, the sort to variable which has the all the words which are arranged in the decreasing order of the frequency as the input to the word cloud. We have seen, right? Already we have come up with the word cloud. I'm just coming up with the word cloud with two words together. And you can see these are the two words which are printed together. There are various ways to come up with the bigram, guys. This is one of the easiest ones. You use the inbuilt function and tokenizer. All right. Now, coming up with the positive word cloud and negative word cloud. So we have seen unigram, we have seen bigram functions. Let us now do positive words and negative words generation. So I load positive words. Read lines is basically helping us to generate or read the content, text content. So I'll navigate and I'll choose the positive words.txt file. Same text file that I've used yesterday for Python, same text file. And it has 2006 positive words. You can see here on the right side, 1:2006. Similarly, I'm reading the negative words. Negative words.txt, it has 1:4783 words. You can also add customized stop words. Previously, we have loaded only the inbuilt stop words, right? Now I have loaded the custom stop words, which has 571 words defined as stop words. If you want to use this, you can filter the words using these stop words. Next, we are taking the words w underscore sub 1 is the mix of all the 3081 words arranged in a sequence, decreasing order, right? So I'm taking those words, considering the names of those words, in that variable, and then I'm matching that with positive words. Match. So when you do this, it is going to say true or false. If the word is present in the positive words dictionary that you have defined here, which has 2006 words, then it is going to say true or false. Right? NA or that index, basically it's another way to represent. Here you will get true or false. Sorry. So when you do this match, it says what is the matching? Names and positive words. So if I go to the first word, okay, the second word is there in 832 position. Right, in your stop words, there is a word which is positioned at 832, which is similar here. Both are same. Then this word is 875 matching. So on and so forth, it is matching the words and giving us the index. Next, I'm saying choose the positive words from this which are not NA, is not NA from this positive matches. So filtering out all those NA positions, all the NAs will be removed. Right? So if you see here, the second one will be true. Let me go there. Yeah, second one would be true. Because it is not a NA, right? The first one is NA. So it is showing false. Right? Now, take W underscore sub 1, but use this positive matchers. So you're taking the index value or the value which is having true here. So your frequency underscore positive words would be those words which are repeated or which are present in the positive dictionary. right? These are all the positive words. You are just mapping, comparing with the positive dictionary, identifying the indexes in your W underscore sub one, and choosing only those words. And here I am taking names separately and the frequency separately. Okay, and coming up with the word cloud. Oops. These are the bunch of positive words. You can again arrange the font size and all that scale. You can say different scales. You probably say 1 here, and you might want to re-execute it. So the font size increases now. All right. And similarly, the negative words, the same logic is applied, but I'm using the negative words dictionary. So execute this, execute this, execute this. And you come up with the word cloud here. These are the negative words. So we have generated positive word cloud, negative word cloud. Yep. Now there is one additional function that I want to explain here before we go. This is to generate the speeches. Okay, I think I need to give the right path. This is the folder. I put two different speeches. This is a speech given by Bush, and this is the speech given by Obama. So I'm trying to compare the speeches between, right, these two people, these two presidents. So I will define this directory here. I will have to give the directory location here first. And yeah, typing everything would be a challenge. Yeah. We have to replace this Windows syntax because R or Python don't understand this Windows syntaxes. We have to go with the forward slashes. So this is something manual. Let me change that. All right. So I'm saying this is a corpus. The corpus is basically in this particular location. The directory source is the speeches folder in which I read the data. So it is saying list of 2. The data is list of 2. Okay. Right. And then on this particular data, we are applying the cleansing. So transform everything to lowercase, remove punctuation marks, remove numbers, remove stop words, and you might want to also remove these words which are right frequently used in that particular content. You can add the cleaning things, all those additional things that you might want to add. You can put it there. Then create TDM, convert that TDM into a matrix, and then you are giving 2 columns. It will have 2 columns, mind you. One column is for Bush, the other column is for Obama. So I'm giving the labels there for the column names. And then use this comparison.cloud function. Comparison.cloud function is basically comparing the words and generating those words in the same word cloud. And yeah, blue color and red color, there are 2 different colors that we are coming up with. Let me say Windows. I think that would be better. Come up with Windows and then come up with the, this is better. Bush is in the red color, Obama is in the blue color. And you can compare the colors. All right. So this is comparison.cloud. Right. Before I wrap up, I want to talk about the emotion mining here. Okay, there is one part that I want to show. All right. Okay, let me clean this off to make sure that I don't have less memory. And NRC data, right? So I need SV. So let me load the data here first. Where's the SV? Huh. Okay, emotion mining. This is the part that I wanted to execute. So I have the library size it, and let me read the data here. I'll replace this with read lines. Fine. Okay. So what I do is I put this command here, where I've used this word clouds, right? File.choose this command. I'm retyping it, okay, like this. Okay. So the content that we have extracted, right? I'm loading that content, reviews content, 1 plus 60. Okay, and I'm splitting that into sentences. Got it? Then you can see get sentiment. Now, what this get sentiment function is doing is it is converting that sentences into numeric representations. It gives you polarity. If you see head, okay, all the 6 are probably the empty ones. If I try to do only sentiment vector here, yeah. So there are negative sentiments, there are positive sentiments as well, right? So these numbers that we are seeing are the sentiments that are given by the customers in their reviews. They are not happy. Based on the Bing framework, it's a dictionary, we give value to each word and then calculate that value here for complete sentence. This is Bing is one dictionary. FN is another dictionary that we come up with. And let's see if we have anything. Even for FN, we don't have the first 6 with any positivity or negativity. But yeah, we do have positive and negative. Similarly, NRC framework. This NRC framework is another third dictionary that we have. And if I see NRC framework, it also has these different sentiments. You can use the statistics here, different calibrations to get the overall sentiment. If you are doing it using Bing framework, what is the overall sum? 854. So it is overall positive sentiment. On an average, it is close to neutral, 0.212. And if you say summary, yeah, negativity is also there. Minimum value that we have is -4. Right? So sentiments are there, positive and negative. You can plot the sentiment trajectory and you can use this trajectory to see that more positivity is there, less negativity is there, but there are few customers who are also unhappy with the product. Right? So this way you can come up with the visualizations. You can also try and understand what is that specific review which is the most negative review. Overall, among all the customer reviews, what is that one review which is the most negative one? So you say which minimum, it gives us that minimum sentiment. 60 has one strange problem. Whenever the Wi-Fi hotspot is switched on with Bluetooth headset connected in parallel, there is very serious of signals and Bluetooth audio gets disrupted. So this is basically the review which is using a lot of negative words. So it has the maximum score. Similarly, what is that review which is having the highest positive score? So you say positive. This is the sentence which has the positive feedback. So it's a lengthy feedback, but the customer was happy and he was basically using all the words which are giving us a very positive polarity, right? Yeah. So that's about your most negative and most positive. Let me not run this. Let me go to this part where you need to actually understand the different 8 emotions. So I'm using NRC framework to get the polarity on that particular sentiment. So this is your NRC. Sorry, this is the function, my bad. So it is now capturing the polarity of the words used in the sentences or the reviews of the customers. You're trying to grade them using NRC framework. And let's see. Still doing it. It's taking so much time to calculate the numbers, polarities. Yeah, done. So if you see head of SV, these are the sentences that we captured. Okay, all these are junk characters, I mean empty spaces and all that. We have not done cleaning properly. Okay, so otherwise you'll not see all this. So let's not run this because it will be 0 only. Now what we are doing here is there are 8 different emotions that we can capture. Okay, let me show you head of NRC underscore data, though it will be zeros. You can see that it has 8 different emotions: anger, anticipation, disgust, fear, joy, sadness, surprise, trust, along with negative and positive polarity. I am saying capture those words or those reviews where people have sadness. They expressed sadness. Capture only those feedback. And those things will be there in your sad items. So these are all the reviews where customers expressed sadness. Similarly, you might want to check what are those reviews wherein customers were angry, because that is also one of the right expression or emotion. Address these issues first. Talk to them. Why they are getting angry, why they are sad. Address these issues, and that's one way to gain the confidence of your customers. Right? Now I can represent these 8 emotions in the bar plot. And if you see, customers were anticipating the right features or their primary emotion with respect to this mobile phone was anticipating a specific, probably a feature. They trust the phone. They are happy. Then there are a few customers who are angry. They were surprised about few features. There are customers who are sad, they are fear. There are a certain amount of people who are disgusted as well with the product. So target these areas, right? Target these areas which are going to help you gain your customers' confidence. This is called as emotion mining using parsers, especially NRC framework, right? Yeah. We are measuring the polarity of the sentiments, right? Yeah. So yeah, this is basically the conclusion. This is what I wanted to show you. Let me take your questions now. I guess there will be in YouTube where we'll get YouTube, right? I was explaining that, Roshan. I was saying that the videos will be there in YouTube channel. Yesterday's video and today's video will also be there in YouTube. You can go through that. Probably today, before end of the day, you will have the videos uploaded, or max by tomorrow morning. A weekend, right? So I cannot push my people on over weekend, but I'll try to get it uploaded by today, end of the day. Shantanu, most of the R codes are already available in your LMS in text mining module, and I'm getting these other additional LSA, LDA and modules uploaded into the bonus module in your LMS. Again, in before end of the day, you will see these codes in LMS. Yes, Rohit, you can remove those emojis. Ultimately, emojis are nothing but special characters. We add few characters, and those characters are right converted into emojis. Yes, we can do the cleaning for emojis as well. Roshan, as I said, the 5 videos are from Monday to Friday. Yesterday's and today's videos will get updated. I may be able to follow the file on the computer code. But Pranesh, it should be there in our LMS, especially the R code should be there already. If it is not there, you will have it by end of the day today. RWeka is not loading. I see something related to Java error. So you have to make sure your Java is properly loaded. Java is there present in your system and it is mapped to your RStudio. You have to verify from that side. If your Java is set properly, then you should not get these issues. All right. Yes, Rashid. So today is the last class for this NLP. And from Monday onwards, you will follow your regular classes. Yes, we will be loading those positive and negative text files also into the LMS. But I would recommend you explore and try to get new words, because these words will be very generic and specific to a specific product. To begin with, for practicing, yes, you can use them, but don't interpret the results using them. Shiva, that's what I'm explaining, Shiva. The R code and the Python codes, the codes will be there in your LMS. I will get them uploaded. All right. All right, so we'll conclude the session here. There are additional codes also. Please run through these codes once they are uploaded into your system, into your LMS. Practice on them, right? So we will be covering a few things as and how we proceed further in our regular classes. Yeah. Rishikesh, I am not deciding that. It's predefined parsers, dictionary. Based on the dictionary, the statisticians have defined that a specific word has specific emotion. The same word might have value for different emotions, right? So it's depending on the parser. Yeah, thank you guys. Yeah, sure, Raghunath. Yeah. Hey, thank you guys. Thank you. All right, friends. So just wait out for 1 day and check your LMS And if you still do not have it, you can always right, contact me. You know my contact. You can always get back to me. I'll get that right, corrected if these words, the codes are not approved. Okay. All right. So let's conclude. Yes, Pranesh, you might want to right work on those assignments. Yeah. Thank you, friends.